Okay, I want to walk through some examples for your Chapter 7, the valuation characteristics of bonds. This is starting on page 199, and this is how to calculate the present value or price of a bond. We're told in this problem that the required rate of return, and that's the required rate in the market, what an investor expects right now. And on this particular bond, it's a fairly low rate. We'll put in 0.0248%. It has 4 years till maturity, and then the annual interest payment is based on the original interest rate paid on this bond. So at $45.50, and we can figure that out from the original coupon on this bond of 4.5%. So there's a couple ways we can do this, but I'm just going to do it this one. We'll say equals 1,000, and then just say times, and we'll put in 0.045. Okay. So that's what somebody would receive if they had bought this bond, $45 at the end of every year. The future value, I'm always going to put that in as $1,000 because that's what I will receive in the future when it matures. And with bonds, the par value, just assume that it's always going to be $1,000 when it matures. And what we're trying to do is we're trying to solve for the present value of this bond. So if I go to the f of x, highlight f of x right here, I'll go to financial again, type the letter P, get pretty close to present value. So I'm going to hit present value, hit OK. So again, we're told the rate. I have the information here, but I'm going to type it in myself right here too. But the current rate in the market is 0.0248. Again, this is what investors could receive. So right now, the rate is much lower than the original coupon rate, and that was the 4.5%. So this bond would be selling at a premium. Number of periods is 4 years. The person will receive $45. I'm just doing this slightly different than the textbook because I want to try to show that it's positive cash flow to you if you bought this bond. And a future value of a positive 1,000, saying that it always would be at $1,000. And from our example, let's see here, I just need to change that payment to 45.50. And then if we have that, okay, yeah, it matches up to the textbook of $1,077.91. So this is what an investor would pay for the right to buy this bond. So we hit OK here. All right. Now, a slight change here is most bonds in reality pay semi-annual interest rates. So we just have to make some modifications to the number of period, the rate, and the payment. But I just think of it as that we're either dividing by 2 or multiplying by 2 in each example. So in this particular case, I believe that we're using the same bond, but we just have to change some values here. So I'm going to go into present value again, f of x, find PV. And before I do that, let me go ahead, let's just put in the values for the sake of putting those in there. So we have 0.0124, we got 8, and again, I'm going to, if you think of it like the previous example for the payment, I'm going to take equals 45.50 and divide that by 2. So it's saying that somebody get $22.75 every 6 months. Again, it's slightly different than the convention in the textbook, but I just kind of like to show it this way from the cash flow perspectives. $1,000 for the future. Again, always a par value of 1,000. Okay, now to calculate the present value. So do f of x under financial, type the letter P, gets us close to it. Put present value, hit OK. The rate, I'm going to put in as 0.0124. Number of periods, I need to double it. So if I say 4 times 2, 4 years, but semi-annual. The payment again was from the previous page. You think of, say, equals 45.50 divided by 2. Let me just take that equals out. Say 45.50 divided by 2. I get the 2275. And again, the future value is always going to be 1,000. Okay. So we hit OK, and you would pay $1,078.36. Notice a little bit more because you're getting the interest more frequently. All right, last one dealing with yield to maturity. This is the rate of return to the investor if you held onto this bond for a certain amount of time period, being the full length until it matures. So the example on page 202, we're told there's 10 years till maturity. So let me take that out here, a number of periods here. 10 years till maturity. The annual interest payment is $90. So that means that on the original bond, if we think of it was originally at 90%, equals 1,000 times 0.90, 0.09, let me change that, 0.09, $90. We said future value is always going to be 1,000. In this case, the person paid $1,100 for the right to receive this $90 every year. So we have to figure out what is the yield to maturity. So I'm going to go to FX, under financial, we're going to find rate, type in the letter R, brings right to it. Number of periods here is 10. The payment, $90. Present value, so we paid negative $1,100. And finally, the future value is 1,000. Okay. And if we hit OK, and again, it's a good idea to format these out to about 4 decimal places in Excel. So I'm going to go up here in percentage, just increase it. So the rate of return to the investor is 7.5404%. All right, last concept with current yield. Current yield is often what's quoted in papers, but it's really just the interest you receive during that time period divided by whatever price you paid for it. If we look at the example on page 202, they give us an example where somebody had received $80 every year, 80 in an interest payment, and the amount they actually paid for this bond, or the current market price of the bond, was $700. Market price, 700. Okay, so if I were to take the 80 bucks divided by that $700, okay, we get about 11.43% rounded up as the current yield. Again, current yield is much different than yield to maturity because it's only looking at that specific year. The interest you receive divided by whatever price you pay for that bond. And that ends our general lesson on calculating present value bonds, yield to maturity, and current yield.